And welcome back. It's the 5th of April, higher plus 5 a day, and let's just go straight to the first one. Right, what do we have? Draw the graph for values of this. Okay, I'll just read the second part. This is one of those questions that I know a lot of people find difficult to start with. So let's go through this one properly. So almost always it either gives you the first graph or asks you to do a bit of sketching to start with. So let's deal with a bit over here. So let's draw the graph of something between -2 and -3. Now, because I'm going to need these values a bit later on, I'm going to do this reasonably accurately. So -2, -1, 0, 1, 2, 3. And then x squared minus x is going to be 4 minus -2, which is 6. Now, you do have a function in your calculator that will do this for you. It's called the table function. But I'm just going to work these out quickly. So 2, 2, 0, 1 minus 1 is 1. It's 0, sorry, 3, 2, 2, and 3 squared minus 3 is going to be 6. Yeah, I'm happy. And actually what's notable, just on the side, it's a quadratic, so I can see I've got symmetry here, and it's around the middle. So I'm happy I've done the right thing there. If it didn't look like a quadratic, I knew I'd made an error. Anyway, let's get graphing. So -2 against 6, so -2 against 6. Note the scale is not brilliant. Let's zoom in a little bit. -2 against 6, -1 against 2, which is here. Now, in an exam, you will have a much better piece of paper to do this with, as in a much bigger scale, much easier, not trying to squeeze it in like I am trying to do right now. Also, I suspect you'll be able to read your squares a little bit better. Okay, now, because it's a quadratic, you cannot have, let me draw it, can't draw and talk. You cannot have anything square or too jagged on the bottom. So it needs to be a nice smooth curve on the bottom like this one here. I will say here I've clearly missed that value there, but in the exam do a better job of hitting all the points precisely to what I've done. Anyway, to the hard part. By drawing an appropriate linear function. So that's the clue in the question. It wants you to do something specific. Now it wants me to solve x squared minus 3x plus 1 is equal to 0. I've already solved, in other words, I've already drawn x squared minus x. So if I could turn this into x squared minus x and see what the difference is, I then have a simultaneous equation. So let's do that. So let's just see what I need to do. So you know that I've got my x squared, so my x squared is x squared. I want 3x to become minus x. Well, I can't just add 2x, but I can add 2x to both sides as long as they cancel out. So the 2x moves over here. Remember, this is equal to 0, so I've added 2x to both sides. Similarly, I don't want the 1, so I'm going to take away 1 from both sides, and that gives me the equation I've already graphed and the equation that I need to graph, and where these two things are equal is where this is equal to 0. Clever question. It's one of these things that you're really hard to work out in the exam if you've not seen it before. Anyway, point is I need to graph y is equal to 2x minus 1. Again, this is going to be rough and ready, but it's going to be fine. So y, if I'm going to do it in a different colour. So y is equal to 2x minus 1. There's my minus 1. Actually, let's do some plotting so it's right. So I've got x, y, minus 2, minus 1, 0, 1, 2, 3. And then, so minus 2 times minus 2 is minus 4, minus 1 is minus 5. Then I'm going to keep adding 2, so minus 3, minus 1, 1, 3, 5, and 2 times 3 is 6 minus 1. Good. Okay, so let's plot some of these points. I don't have to plot them all. So minus 1 goes against minus 3, which is here. 0 goes minus 1, done that one already. 1 goes against 1, which is here. 2 goes against 3. Now, in an exam, it is important you do all this properly. 3 goes against 5. Because the next part you're going to have to be accurate for. So again, allowing for the fact I'm doing this on an iPad, and allowing for the fact that my line isn't anywhere near straight, basically as accurate as possible, I want to measure what these intersection points are here. So let's zoom in. Now look at my scale. Each of my little squares is 0.1. So that's going to be 0.1, 0.2, 0.3. It's a bit more than 0.3, but let's call it 0.3. So x equals 0.3, or on the other side, it's 2.1, 2, 3, 4, I think, or 2.4. Now, I did not do a great job of doing that super accurately, so I don't actually know what the answers are. In fact, I'll tell you what I'm going to do is I'm going to use my calculator to tell me the answers and then actually see how far away I was. So I'm going to use a function in my calculator, a solving function. I've got an A-level calculator, so I can do this. So 1 minus 3, 1. So the actual answers are 2.6. and 0.4. So I wasn't miles away. Again, a bigger scale, more accurate, better plotting, I would have got a lot closer. But the point is, that's how you do those questions. I'm reasonably okay with that. Next question. What do I need to do? Express this in this form. Right, so I'm going to change the 4 into a 2 by recognising that 4 is the same as 2 squared. Then I'm going to multiply that by 3x plus 5. In other words, I'm doing 2 to the 2 to the power of 3x plus 5. Using the bracket rules, I know that is 2 to the 6x plus 10, and that's equal to 2 to the y. And just by straight comparison, it must therefore be the case that y is equal to 6x plus 10. That one wasn't too bad, was it? Not after the previous one. Next question. There are x, okay. Now, you don't need the history here, but quick history. So about 2017, I think it was, they created this famous question called Hannah's Sweets. You can Google Hannah's Sweets. And basically, they've started asking lots of questions that are similar, which is a probability question where you need to build up some algebra and solve the algebra. So what do I have here? So there are X apples in a crate, 2 apples are bad. So therefore, the number of bad apples is 2 over X. Jesse chooses 2 apples from without replacement. Okay, so 2 apples from the crate without replacement. The probability that he selects 2 bad apples is 1 over 28. So what you need to do here is it's basically a clever conditional probability question. So I'm doing 2 over X times, well, there's 1 less bad apple and there's 1 less apple to choose from. And I know the probability combined is 1 over 28 because it tells me the question. Now, I'm trying to prove that this is true. So keep the number 56 and minus 1 in your head, because that's where I want to get to. When you see a 56, you probably know you're on the right route. So the first thing I'm going to do is I'm just going to make this a little bit neater. So that's 2x squared minus x is equal to 1 over 28. Then I'm going to multiply both sides by 28, which is going to be 56 is equal to, and both sides by x squared minus x. And already you can see this coming together. Actually, there's only one more step, isn't there? So therefore, x squared minus x, bring over the 56, is equal to 0, and I have proven that to be true. Little square just means I've proven it. And then again, pretty consistent sort of question here. Next part, find x. In other words, I've got an equation which tells me what x's are going to be. I want to know which values of x give me 0, and that's going to be where x minus 56 is 8 and 7. So x minus 8 x plus 7 is equal to 0, which means that x is equal to 8 or minus 7. X is greater than 0, so therefore x is equal to 8. Then always go back, quickly check you've done the question. So find x, the number of apples. I've done that. Sometimes it might say find the number of bad apples, or it might say find the number of, whatever it might be. But the point is, quick check of the question at the end. And that's it. It's definitely getting a bit harder. And I think this month as a whole, we'll start to see some newer questions. So stick with it. Do let me know how it went for you. Like, subscribe, and I'll see you tomorrow. Thanks all.